Video is an introduction to arrays. This is actually the first video for Engineering Models 1. The purpose of these videos is to introduce you to the concepts that we're going to be discussing for the week, to allow you to practice a few things in MATLAB, and finally to test your initial understanding of the concepts by taking a quiz at the end of the video. This will allow us to spend time in lecture solving problems, getting you prepared for recitation, and getting you prepared for follow-up homework assignments. So what is an array? An array is a collection of like elements, and for now those like elements are going to be numbers. There's lots and lots of different engineering applications that use arrays, and all of the numerical computations that MATLAB does are array-based, so it's important to understand array operations. In fact, the word MATLAB itself is an acronym that is short for Matrix Laboratory. Start off with one-dimensional arrays. A one-dimensional array is also called a vector, and some of you, depending on what you took in high school or in previous classes, may have actually heard of vectors. A vector is a one-dimensional array. Couple of examples: a row vector would just be a row of numbers. Column vector could just be a column of numbers. So how do we create a vector in MATLAB? Well, we actually have several different options for doing this. First option, alright, I can just go to the MATLAB command prompt, create some variable name. In this case, I'm going to call my vector A, and I can just type in a square bracket, start typing in numbers separated by some white space. You could also cram them together and separate them by commas if you want, but I think the white space is a little easier to read. And if I do that, I get a vector containing those numbers, a row vector. Another example, again, start off with some sort of a variable name, B, square brackets, type a number, semicolon, next number, semicolon, next number, semicolon, and that gives me a column of numbers. This works fine if you only have a few values that you want to enter into your vector, but you can imagine if you had 200 values that you wanted to enter, it would get old really fast. Couple other options. All right, in this particular example, I'm going to create a vector called T. The first number that you see here, -1, will be the first entry in my vector T, so that's my starter value. Then I have a colon followed by a second number. That second number is my increment. In this case, my increment is 0.5. So I'm going to start off at -1, and I'm going to keep adding 0.5 and 0.5 and 0.5. So my first entry is going to be -1. My second entry would be -0.5. My third entry would be 0, etc. When do I quit? Well, that's what that last number means. Colon 3 says that I'm going to quit before I exceed 3. So if I do this command in MATLAB, here's what I get. All right, notice I start at -1. I'm incrementing by 0.5. and my last value in the T vector does not exceed 3. You can leave out that middle number. If you leave the middle number or the increment out, MATLAB will just assume that you want that increment to be 1. You can also have that increment be a negative number, in which case you're actually decrementing through your vector rather than incrementing. Here's a second example. So my starter value is the same and my maximum value is the same, but that middle value, the increment, is a little bit higher. It's 0.6 in this case. Here's what I get. Again, my first value is -1. It's a match to the starter value. And you can see that I'm incrementing each time by 0.6, but in this case my very last value is 2.6. It is not 3. And the reason for that is if I get to 2.6 and I add another 0.6, that would take me to 3.2, which exceeds my maximum value, so this one terminates at 2.6. Third option, use something in MATLAB called the linspace command. So again, I'm creating a vector called t, and I have t equals linspace. The first entry in linspace is my starter value. So the first entry in my vector t will indeed be -1, like the previous example. The second entry in linspace is my ending value, and notice I've marked this as end and not max like we had in the previous slide. This is because with the linspace command, your last entry truly is going to be that second argument. My last entry in vector t will be 3. The third argument is how many points you want to have in your vector t. So in this case, I should start at -1, I should end at 3, and I should have a total of 7 data points. And that's what I produce. MATLAB will go ahead and calculate what the increment is that's necessary to give me equally spaced values that start at my starter value of -1 and end at my ending value of 3, and provide exactly the number of data points that I asked for. So now we're going to go into a little bit about array operations. We're going to talk about entry-by-entry math operators provided by MATLAB. Alright, so suppose I create a vector t. I have t equals 0, 2, 10. So I know this is going to give me a starter value of 0, an increment of 2, and I'm not going to exceed 10, and in this case my last value actually ends up 10 because I have that nice even increment of 2. What if we wanted to square each entry in the vector t? What would you guess that you would do? Well, most of you, if you haven't had any experience with arrays, and even if you have had experience with arrays, might think, hey, well, I've got this power operator in MATLAB, so I can just do t raised to the second power, and that ought to square each of those entries in the t vector. And if you try this in MATLAB, you'll find out it doesn't work. I get an error statement. Error using the power operator. Inputs must be a scalar or a square matrix. MATLAB goes on to give you a hint. To compute element-wise power, use dot power instead. So what's this all about? MATLAB has a set of arithmetic operators. We talked about these in the first recitation section. It can add, it can subtract, it can multiply, it can divide, and it can take things to a power. But all of these arithmetic operators have to follow the rules for arrays. And let's see what we're trying to do here. If I'm trying to take t and raise it to the second power, t raised to the second power is the t vector multiplied by a copy of itself. Most of you have probably never seen any matrix math at all. But for those of you that have seen matrix math, that t vector is a 1×6 array. It has 1 row and it has 6 columns. So I'm trying to multiply a 1×6 by a 1×6, and it doesn't work because those two middle numbers, referred to as the inner matrix dimensions, are not the same. So this is an invalid operation, and hence MATLAB says nope, can't do that. The only things you can raise to a power are scalars or square matrices that have the same number of rows and the same number of columns. But this isn't really what I want to do anyway. What I really want to do is I want to go inside of that t vector, and entry by entry by entry, I want to raise each entry to the second power. And this is something very useful. So fortunately, MATLAB provides a way to do this. MATLAB provides a set of what's called entry-by-entry operators. And the entry-by-entry operators are dot times, dot power, dot divide. Notice there's no dot plus or no dot minus. This is because addition and subtraction in array operations are entry-by-entry operations, so there's no need to have a dot add or a dot subtract. So now if we go back to the example, look at that t vector that runs from 0 to 10 in increments of 2, and we want to square each entry in that vector. It's pretty easy. All I have to do is remember to put the dot in front of the power operator, and I can see that each entry in t gets squared. And luckily, if you forget to do this in MATLAB, you get that nice error statement that reminds you that you need to do that. Alright, so that's an introduction to one-dimensional arrays. And now it's your turn. What I've given you here is a set of commands. Take these commands, open up MATLAB, put the commands into MATLAB one step at a time, and see if you understand what each of these commands are producing. When you finish doing that, come back to this video, hit play, and go on and take the interactive quiz that follows. Alright, so hopefully now you've done your exercises in MATLAB. You've got some kind of a grasp on this concept of one-dimensional arrays. Take the quiz and see how it goes.